Today we're going to do a crash course on Terraform, one of the most important infrastructure as code tools out there. And infrastructure as code basically means we have declarative config files that define our infrastructure. Docker Compose basically does the same thing with containers, but Terraform goes beyond that. We can do everything with Terraform. We're not just focusing on containers. We can do AWS services, GCP services, Azure services, Docker containers. We can define, easily create, and also easily destroy pieces of infrastructure, and we have config files that we can run and reproduce the same environment on different systems. So if you've ever worked with these cloud providers before, like AWS, Azure, or GCP, you know what the web interfaces look like, you know what the command line tools look like. You have to run a bunch of commands, you have to click a bunch of things to create users, to create storage, to give permissions and stuff like this. And the moment you want to undo everything, you have to go through all the steps in reverse. So you basically have to do a lot of manual work. And if you always want to do the same thing, if you want to spawn and also destroy the same architecture, the same ecosystem every time, it makes sense to define it in a config file and to just spawn it and despawn it. If you want to call it that, it's called apply and destroy in the context of Terraform. But that is the power of this tool. So I would say that this is one of the most important tools to have in your arsenal if you want to go into the direction of ML ops or also DevOps in general. It doesn't have to be focused on machine learning, but I recently mentioned how important this field is going to be in the future, or how important it already is. And AI is not going to replace you easily in this field, because orchestration, thinking about system architecture at this level is quite complex and requires humans. And also, of course, you can mess up a lot. So this is a very lucrative field, a very future fit field, I would say. And if you want to go into that direction, Terraform is one of the most important skills to have. So this video today is going to be a crash course or quick start guide. I'm going to show you how to get started with Terraform. We're going to keep it super simple, focused on simplicity, on speed, getting results quickly. This is not an in-depth exploration of all the different features. This is just probably less than an hour. You can see the time down below, around an hour, less than an hour, a crash course and introduction into Terraform, so you can get started with it. Then you can go deeper on your own, or if this video performs well, I can also go deeper in a second version or second episode of this crash course. So enough of the rambling now. If you like this video and if you get value out of it, let me know by hitting a like button and subscribing. And now let us get right into it. All right, so we're going to jump right into the installation. For this, you want to go to the Terraform website, which is actually part of the HashiCorp website. So the URL is developer.hashicorp.com/Terraform, or you can just Google Terraform and it will take you to this website. Then you can click on install to see the installation guide. Quite simple. Depending on your operating system, you have different commands that you can run, different binaries that you can download. On Mac, you can use Homebrew or the binaries. On Windows, you have the installers. On Linux, depending on your package manager, you have to run different commands. Now, interestingly, they don't have an Arch Linux command here for whatever reason, or at least I don't find it. So if you are on Arch like I am, you can go and just install the pacman package here by saying sudo pacman-s Terraform, and this will get it onto your system. It's not really complicated. I assume most of you guys watching this are quite technical. You will be able to get Terraform onto your system. So then you can just confirm it, Terraform, and then -- version to see that you actually have it. There you go. And of course, the next step is we need to actually work with services. To see what Terraform can offer, we need to actually spawn some services, create some services, destroy some services. And we're going to keep it simple. We're going to keep it very proof of concept like. So we're not going to build any fancy systems. I'm just going to spawn some S3 buckets, some Google storage buckets. We're going to work with DynamoDB on AWS. We're going to create some users with IAM. We're not going to go super fancy, but we still need to have the account. So for that, I'm going to use AWS today. For the majority of this video, we're going to focus on AWS, but I also want to show you, for the sake of completeness, one simple Google example, so GCP example, and one simple example using a local Docker container, just so you can see that we can work with different providers here. But it doesn't make sense to cover everything that's possible. I just want to focus on simple examples, mainly AWS, a little bit of GCP, and a little bit of Docker. But that is what we're going to need. For this, if you want to follow along, you also need to have the AWS CLI. This, again, is just the Arch Linux package here. There's different ways to get it on different operating systems. We're going to work with the version 2 CLI. And also, we're going to work with the Google Cloud CLI, which in this case is an AUR package, but again, available for different operating systems in different ways. So to summarize, we're going to install Terraform. We already did that. We're going to use AWS. We're going to use GCP and Docker. Now, my goal with this video today is to give you an introduction into Terraform that's as simple and as quick as possible. Because of that, I want to start with the most fundamental, most basic, most minimal example possible that is still useful, because you can also just print hello world with Terraform. That's not useful. We do want to actually do something in the cloud. So we're going to start with AWS, and we're just going to create and destroy a simple S3 bucket. So we're just going to automate this with Terraform, and I want to show you the difference here in the procedure. Now, the first thing that we're going to do is we're going to sign into the console. I'm going to assume that you have an account already, otherwise just create one. And with our root user now, we're going to go to IAM, so to the Identity and Access Management. We're going to go to IAM users, and we're going to create a new user here, which we're going to call tutorial user. And we're going to go to next. We're going to give directly policies to this user. We're going to attach policies directly. And for the sake of this tutorial, I'm going to keep it simple. We're going to give more permissions than necessary, but I'm going to give this user the permission to sign in local development access so that we can use it in the command line. And we're also going to give it S3 full access, which is way too much in production. This only makes sense if you're making a tutorial video, if you're learning, if you're playing around. In production, you want to give more granular permissions, only the ones that are actually needed. Here, we're going to keep it simple to not confuse you with AWS stuff. We're just going to say Amazon S3 full access. You can do everything you want with S3, and we're going to create this user. So this user now exists, and what we also want to do is we want to give this user in security credentials access to the console, so we can actually log in with this user, because we're going to need that for the authentication with the AWS CLI version 2. So just click enable console access, choose a custom password or auto generate one if you want to, and then we can click enable console access. So this now creates our user. Important, you want to note the account ID. So this thing here, this is something that you need to keep in mind, because that is what you have to enter when you want to log in with this user. And you can find it also at the top right with your root user. You can see neural9 in my case, and then the same number. That's what we're going to need if we want to log in via the command line. So I'm going to log out now. I'm going to say sign out, and then I'm going to open up a terminal. I'm going to say AWS login and -- profile, and I'm going to also call this tutorial user here. So this is what I put in. I'm going to say EU Central 1 is my location. This is going to now open in the browser the authentication flow. I'm going to click on this button here, and I'm going to log in with the IAM user. Here now in account ID, I want to paste the number that I copied before. So here I'm going to paste the account ID. Here I'm going to say tutorial user that we just created, and here the password that I chose for that user. Then I sign in. You can see it has been shared successfully. Here I'm logged in successfully. Now I'm using this profile tutorial user using the AWS CLI version 2. Now, let's go ahead and do the minimal example. I'm going to navigate to my tutorial directory. This is where I want to be working in. And in here, I'm going to create the first file, which is going to be called main.tf. And TF obviously stands for Terraform. So I'm going to create this file. I'm going to go full screen here. I'm going to zoom in, and we're going to define the very basic action of just creating an S3 bucket, and that's it. And of course, we can undo that. I'm going to show you the commands for all of this, but let's define it first. We're going to say Terraform. That is the first thing we want to write in here. Curly brackets, and let me just reopen the file to get the syntax highlighting here. But Terraform is the first thing, and then we need to say that we want to access AWS. So we're going to require providers, required providers. And in here, we're going to specify that we want to have the providers, the plugin basically for working with AWS. It's an official one from HashiCorp. So I'm going to say AWS is equal to, and then I have to provide the source. The source is going to be HashiCorp AWS. And then for the version, I'm going to provide a funny arrow 6.0. So that is the first thing. Then I want to use that provider. I want to say provider and then AWS. And I can hard code some values in here, like region is the one we specified, EU Central -1. And then the profile is the one we created, which is tutorial user. So this is just a provider. Now let's define a resource, which is going to be our S3 bucket. For this, I'm going to say resource, and I'm going to call this AWS S3 bucket. So that is the identifier. This is the type of resource I'm creating. And the name can be whatever. I can call this test, for example. And that is my resource. I can also provide a prefix for the bucket. So bucket prefix will basically add a certain string before the name that it generates for this bucket. So I can say test bucket, for example, dash, and I can say force destroy equals true. And then we can define an output that we want to see in the command line. Let's call this the bucket name, and the value of this output shall be equal to AWS3 or AWS S3 bucket, and then the name of the bucket test.name. So that is basically a minimal config. What this does is it just creates an S3 bucket with a name test bucket and then something random. This is just a prefix, not the full name. And that's basically it. It outputs the bucket name. That is exactly what we're doing here. Now, with Terraform, we have different commands that we can run. The command that you actually want to run later to spawn this, to create all of this, is apply. So you do Terraform apply, and that is the Docker Compose up of Terraform, basically. And then you also have destroy to reverse everything, to remove everything again. Now, you also have commands like format. Terraform format, FMT, basically formats the file to have the correct format. I think mine already had it, but this is something that you can do. And also you can validate. Maybe you have a typo, maybe you forgot something. You can do Terraform validate to see if and right now you can see here actually, that the provider, and this is the next command I'm going to talk about, the provider is missing. So I'm requiring AWS, but I don't have it. So in this case, this is not valid and it will not run. So what I need to do is I need to say Terraform init so it can download the provider for AWS. And every time I add something new, a new provider like GCP, for example, or local file or something like this, I need to also do Terraform init again. So now I have it successfully initialized. Then I can do again Terraform validate. This will tell me if everything is proper. Right now, you can see that I actually included a typo. So on line 21 in bucket name, it goes for name, but it says that this is not the right attribute because of course it's called bucket. So if I go into main.tf down here, the correct name here for AWS is bucket. So I have to change that. Now I can validate again, and it will tell me that now the syntax is valid, the configuration is valid, I can use it. Now, I don't have to run it right away. I can also see what the plan is. So I can say Terraform plan, and it will tell me what it's going to do without actually doing it, without actually asking for permission. And here it tells me basically what it's going to apply, all the changes it's going to apply. One to add, basically just a bucket, and then it will output the bucket name. And this is going to be known after apply once the bucket is created. So with this information now, I can just go and say Terraform apply. And this is going to run it actually. This is going to actually spawn or create the bucket. I can say yes to confirm, and this will then take the action and return the bucket name, as you can see here. So in AWS, if I go to the console now, I should be able to go to S3, and I can also do that with my tutorial user here. I can go to S3 and I will see that there is a bucket which was created by Terraform automatically here. So that's my bucket. I can upload stuff into it if I want to. I can delete stuff. And once I'm done using it, once I no longer need that bucket, I can say Terraform destroy, which will undo everything that we did. It will just remove everything that we created and reverse the action. So right now here it asks me again for confirmation, yes, and this will destroy the bucket. So if I reload this page, it will tell me that this bucket no longer exists. That is the hello world example of Terraform. This is what we can do with Terraform. We define stuff in config files like this, and then it creates stuff, it configures stuff, it can also create users, add permissions to users, but that is the most simple way to do that. In this case, we just spawned a bucket. Now, this is not optimal the way I structured it because I put everything into a main.tf file. The convention here is to split it up into files called main.tf, variables.tf, and outputs.tf. So this here can belong to outputs. I can just go and say outputs.tf, and I can put whatever I want to output into the command line. I can put it, actually let me delete that. I can put it here into outputs. Still works, but it's now in a separate file. And also you want to have a file with variables. This can be different because what's the idea of Terraform? The idea of Terraform is not that I just automate it for myself. The idea is that I can take my config, send it to someone else, and they can reproduce the exact same setup on their system. But certain things might differ. They might not have a profile called tutorial user. They might want to use the region EU North, for example. So in this case, you want to create a file variables.tf, which is not really fancy. We just define the variables there, and then we use them in main.tf. So for example, I can say I want to have a variable called region, and region will have a certain description, and this certain description is AWS region, for example. Now it also has a data type. The type of this is going to be string, and we can also provide a default, which is EU Central 1. Now the default is important because otherwise, if you don't have it, every time you try to apply something, it's going to ask you to fill in the data. So it's going to ask you for the information. Otherwise, it's just going to default to the default, EU Central 1. Now we can copy that, and we can do that for two more things, for the project name and also for the profile name. So we can do profile and project name here. So that is going to be the prefix and name, also a string. And by default, what did we call it here? We called this test bucket. Maybe we should not call it test bucket, but test demo, because it's not just a bucket. And of course, we don't want to have this as with a dash, with a trailing dash. We just want to have the name, and then we can format this into a string with a hyphen. And for the profile, we can say this is going to be the AWS profile, and by default, that's going to be my test, or what did I call it, tutorial user. So now I have these three variables, and I can use them in the main file. And I can use them by just saying var.region. If I just want to take the value, same with the profile, var.profile. But if I want to use something like a prefix, I have to do formatting. So I can say there's a string, and then I have $, and then curly brackets here to say var.project name, and then a hyphen. So that should have the exact same effect. So I can still go and say Terraform validate to see if I mess up something, if I have a typo in there, which can occasionally happen. And otherwise I can just say apply, and it will do the exact same thing. It will create a bucket. After I say yes, it will output the bucket name. As you can see, everything worked in the same way. Now I have a bucket again, and now I can do Terraform destroy again to reverse everything. Same functionality as before, but now with the convention of splitting it across 3 different files. So enter yes, and everything's back to normal. And you can already see the benefit of doing that, because usually what you have to do is you have to go to S3, you have to go to DynamoDB, you have to create users, you have to give permissions, everything manually, and then you have to say delete, everything with the mouse here in this UI, or you do it in your command line with different commands, but you always have to rerun the same stuff. With Terraform, you have one config file, you apply it, you destroy it, you apply it, you destroy it, and you can do that across different systems. This is the benefit of using it. Now, let us go to a more complex example. We're still, as I said, going to keep it simple, but I want to add some more services. I want to have a simple setup here where I can have an S3 bucket. I have DynamoDB, which is managed NoSQL, and I want to have a user. So basically, when you do apply, I want a bucket to exist, I want a database to exist with a simple table, and I want a user to exist. And for now, we're just going to say that's the case, but I also want to show you that we can then use this in a Flask application. So I'm going to copy paste your Flask application that uses an S3 bucket, uses DynamoDB, and uses an Amazon user or AWS user, but we don't have to set it up manually. We can just do Terraform, apply, and then we can use our Flask application, and we can do that across systems. So in addition to our bucket, we're now going to add additional resources. So I'm going to say resource. Let's start with the DynamoDB table, AWS underscore DynamoDB underscore table. We're going to give it the resource name uploads. And we're going to call this here again with a formatted string, $var project name dash uploads. That's one thing that we need to do. Also, you want to set the billing mode. The billing mode needs to be pay per request. So otherwise you have to introduce other fields as well. So pay underscore per underscore request. Then we want to define a hash key to be equal to ID. And we can say that this is a string. So attribute, we're going to say the name is ID. And the type, the data type is going to be capital S, which is string. That is that. Then also want to have a resource for the IAM user. So resource AWS IAM user. We're going to call this app. And the name here is going to be also, again, formatted string. So we're going to say var project name dash app. Then we also want to have the access key for that user. So that's going to be resource AWS IAM access key. Also, app is the resource name. And here we're going to say user is equal to And we're going to say that this is the AWS IAM user dot app dot name. So that is going to be the user. And then most importantly, we also need the policy for this user. So this user that is being created here is the user that our Flask application is going to use. And this user needs certain permissions. It needs the permissions to put something into an S3 bucket, to get something out of it, to list the contents of a bucket, and basically the same for the database. So we're going to say here resource, and that is now the AWS IAM user policy. Also again, app here. And the name for that is going to be basically the same as this here, but with dash policy. And also we're going to copy user is equal to AWS IAM user app name. And then we need to define our policy. And the policy is going to be a JSON object. So we're going to say JSON and code. And in here, we're going to pass curly brackets. In those curly brackets here now, we can provide the information for our policy. Now, our policy has to have a certain language version. The version means not the version of the policy, but the version of the language used to express the policy. And AWS, the current one that we should be using, is from 2012. Let me look this up again, 1017. And then we need our statements that are actually going to, or our statement is actually going to define the policy. So this is a list, and in this list we have dictionaries, and these dictionaries are expressions that give permissions to the user. So the first one is going to be for S3, so for the bucket, and for this we're going to say that the effect of this statement is to allow something. And the action is going to be a list of the permissions that we want to give here. These permissions are called S3 put objects. They're called S3 get objects, which I think is self-explanatory, and also list bucket, which I think is also self-explanatory, shows you what's in the bucket. So this allows you to get something from it, to put something into it, to upload basically, and to see what's in it is list bucket. And important, we need to also provide the resource that we want to target. So resource is going to be equal to, and that now is going to be the bucket up here. So that's going to be our AWS S3 bucket dot, and then what did we call it? We called this test. So .test.name, the actual bucket, and then also the formatted string of this bucket. So AWS S3 bucket test name / everything, asterisk. Okay, so I reopened the file to get some syntax highlighting here. The second thing is going to be basically the exact same thing for DynamoDB. So I'm just gonna copy paste this, effect allow, but here now it's not S3, here now it's DynamoDB, and they're called put item, DynamoDB get item, and also scan, DynamoDB scan. And actually, sorry, we're not targeting the name here, we're targeting ARN. And here we need to say that this is our AWS DynamoDB table .uploads.arn as well. So this is now the policy. Now, all this is enough to create the resources to work with them, but I also want to now export all the credentials that I need because I want to have a setup that just works. So what I want is I want to create all of this. I also want to have a .env file with all the credentials that I will need in my Flask application so that I can easily work with that. And I don't want to do anything else but Terraform apply and UV run app UI in the case of a test server now. Otherwise, of course, something like Docker Compose up or something. But the idea is I want to have everything exported automatically. So I can also do that. For this, I just have to create a local file. So this is also a resource, but the type of the resource is a local_file. So this is now a different file, and we're going to call this env. So the file name for this is going to be a formatted string. And here we're going to say again, $path.module, and then we're going to say /flask app, and then .env. We need to create this directory. We don't have it yet, but that is going to be the path to export the .env file into. And for the content now, what we need to do is we need to define it here. We're going to say double arrow here, EOT, and then EOT in the end as well. In between, we're going to provide our key value pairs. So this is going to be the content of the .env file. And we basically just fill it up with key value pairs. So I can say, for example, bucket name is equal to $, and then again in curly brackets, what would this be? This would be my S3 bucket dot test, I think I called it, and then dot bucket. That would be the bucket name. And I do that now for all the relevant things that are going to be used in the Flask application, which we have not created yet, but I know what's going to be needed. So bucket name is one. Another one is a table of the DynamoDB. So DynamoDB underscore table is going to be equal to $AWS DynamoDB table dot uploads dot name. Then we need the AWS access key ID. That is going to be part of the access key that we have. So that's going to be our AWS IAM access key, to be precise, the app ID. Then we also need the secret key. So that's going to be the AWS secret access key. And the secret access key is basically same start, but then app.secret, not app.id. And then finally, the AWS region is going to be equal to var.region. This is our variable that we created. So now if I reload this file here, it should have syntax highlighting, but it messes up here. Oh, actually it worked now. Perfect. So that is just automatically exporting the .env file when we do apply. Now we can validate this. We can say Terraform validate to see if I made any typos. And in this case, I actually did. Yeah, because I have the asterisk in the curly bracket. So I need to actually change that. So down here, we have basically just this /*. And now if I do validate, this gives me missing provider. Okay, that's obviously because I'm using local file now. So I need to do Terraform init again to be able to do the .env export. But besides that, I think we should be good. Okay, no, we have one more mistake. I provided file underscore name. This should actually be file name. So we can also fix that. And now we're good. The configuration is valid. So this is a very useful command, validate. As you can see, I'm a person that if I code myself with my hands, I oftentimes mess up like little typo things like a underscore instead of just file name. And validate just tells you that your file is valid. Now let's go ahead and create a Flask application. This is not at all going to be the focus of this video, so I'm not really going to go into Python or Flask at all. I'm just going to create this. If you're interested in learning Flask, if you're interested in learning Python, I have tons of videos on that. But now we're just going to use this application as a proof of concept that we can easily interact with these components, with these parts of the architecture. So I'm going to go into this Flask app here, uv init to create a project, uv add, and we're going to add the Boto3 package, python.env, and of course Flask as well. Then I'm going to remove the main py file. I'm going to create a new one, app py, and I'm going to copy paste the code. What is the basic idea? We have Boto3, which is for interacting with AWS. We load the environment variables from .env. We have here load.env. We set up the credentials for Amazon, and then we just have an upload route. We can see what files we have in the bucket, and we can also upload files to the bucket. And in addition to that, we're also working with DynamoDB. We have the table here, and we're also putting an item into the table with some metadata. Very simple, very minimal, but it requires everything to be set up. You cannot just run this if the AWS stuff is not taken care of. So in addition to that, I'm also going to create templates here. So that's going to contain just a simple index.html file, nothing fancy. And that's just going to contain our minimal UI. So just showing the files and allowing us to upload. That is our Flask application, nothing fancy. So what do we need to do to be able to run all this? Very, very simple. I just have to say Terraform apply. This is going to create everything in AWS. Or actually, I'm pretty sure it's going to fail because we need to do one more thing before we can get there. As you can see, we don't have the permission to do that because our user, if you remember, only has full access for S3. So it cannot create new users and it cannot create database tables. We're not talking, by the way, about the user that we created here in Terraform with a policy. So we're not talking about this user here. We're talking about the tutorial user that actually manages the creation of this user. So this user is not allowed to do that, which means I need to log out actually, and I need to log into my root account. So I have to go back into my Neural 9 account here. So here with sign in using root user email, I have to provide my account's Neural 9 mail here, and I have to provide my password and then also a multi-factor authentication. And once I did that, I'm back in here. I can go to IAM and I have to go to my tutorial user that is managing everything. So this user right here, I have to go to add permission, add permissions, attach policies directly, And I'm going to give it full access also to IAM. So IAM full access. Again, this is just for quick learning purposes here to not make this complicated because this is not an AWS tutorial. Don't do that in production. Don't give all permissions if not necessary. Same goes for DynamoDB full access, Amazon DynamoDB full access. I'm going to just give both of these to the user. And now the same action should be possible. If I just run Terraform apply again, it should be able to do everything that it just failed to do. So yes, and it should create a database, the user, and the S3 bucket. There you go. Everything is completed. 5 resources added. If I look into my AWS dashboard, you can see if I refresh here that I have a new user test demo app. If I go to S3, I will have a bucket. And if I go to DynamoDB, I will have a table. So if I go here to DynamoDB, I will find a table there. If I go to tables, test demo uploads, so that works. Now I can go to Flask application, UV run app py. This is going to load everything from the .env file. Now I can upload a file. Let's actually go with one of the config files themselves. So main.tf is what I'm going to upload here, upload, and now it's part of my DynamoDB with a timestamp here, and I also have the file actually in the bucket. So where's my tab? I'm confused now. Here I have the entry. So if I go to explore items, I will see that there is the main.tf file here. And if I go into the bucket, I will see that the file is also there and I can even download it. So this is the file and I could download it. This is how you can easily spin all of this up. And the best thing is, if you no longer need it, or if someone else needs to reproduce it, they can also do this. But if you no longer need it, you can say Terraform destroy, and everything's gone. All the buckets, all the databases, all the users, no longer needed, destroyed. Just a yes, and there you go, everything's clean again. As you can see, 6 resources destroyed. If I may for a second, I would like to plug myself in as the sponsor of my own video. If you go to my website, neural9.com, you will find a tab services and a tab tutoring. Here you can hire me for all sorts of stuff like data science, machine learning, web development. If you need help with something in a project, here you can book me for one-on-one tutoring if you want me to teach you personally something that you don't understand. If you like my teaching style, on both pages at the bottom, you can contact me via mail and also via LinkedIn. Just wanted to let you know about this. So that is in general what you need to know. I just want to show you here for the sake of completeness a Google example as well. So a GCP example. We're going to just go with a very basic first example that I showed you with the S3 bucket. We're going to do that with Google Storage. And then I'm going to show you how to work with a simple Nginx Docker container, just so you see that we can spawn different kinds of services. And for that, I'm going to say make directory GCP example. I'm going to go in here into the GCP example. Maybe I'm going to copy the main.tf file from before into this directory, because not everything needs to be changed, I think. Or actually, we do need to change most things, but still we're going to just adjust the config. So I'm going to say Google is equal to HashiCorp Google. Version can stay the same. Provider is going to be Google. And here now we have the region and the project. So I'm going to say project is equal to region is equal to, we're not going to work with variables here. We're going to keep it messy. So I'm just going to hard code the project and the region here. Before we do that, however, we need to go to the GCP console and we need to actually create a project we can refer to. So you want to log into your Google Cloud platform. You want to create a new project. And in my case, I'm going to call this now Terraform tutorial. And that is going to give me a project ID here. I can copy it right away, or I can copy it later if I want to. I'm going to associate this with my billing account. I need to change the project here. So this is now being created. The ID is here as well. I can switch to that project, but I'm for now just going to provide the ID here. The region is going to be Europe West 3, just because I say so. We're going to remove most of this here. I'm going to just write this from scratch. We're going to say resource, and the resource here is Google Storage Bucket. Let's call this test as well. We can provide name is equal to something. We can provide location is equal to something, and we can provide force destroy is going to be equal to true. Now, the name can be something, whatever, test demo dash something. Now, the problem here is we don't have just a prefix. We have to, if we want to have a random number or random string, random ID, we need to generate it here. So we need to create another resource, which is going to be a random number, or I should say a random ID. So random ID, and we're going to call this suffix and that's going to have byte length, which is going to be 4. So I basically want to say test demo and then I want to format into this the suffix, or actually the random ID suffix dot hex. So that is just going to give us a random ID. Location here is going to be EU. That is our resource, our storage bucket here with our random ID incorporated. And the only thing I want to output is the bucket name. So bucket name, and the value is Google storage bucket dot test dot name. So that is basically the same thing as the S3 bucket, just with the Google system. Of course, the authentication here is different. You need to use the Google Cloud CLI, which is on Arch Linux, this one. But once you have it, you basically just say gcloud auth login. This is going to open the authentication in your browser. You just have to select your correct account. You then have to allow everything, and then you're logged in as the correct thing. Now, the current project here is a different one. This is the one I used for testing. So you actually need to say, as it says here already, gcloud config set project, and then the project identifier again. So where is my, there you go, here's my ID. I can just copy this, I can paste it here, and now it sets this as the project. Then again, Terraform init to get the Google module or provider, and then Terraform apply to create storage. And you can also see that apply does validate too. So here right now, true is written in caps or with a capital T, which is not correct. Lowercase true is what we need. Terraform apply, yes, and this is going to create now a storage bucket. So I can just go here with bucket, and this will get me to cloud storage, and I will be able to see in the correct project, of course, the bucket that I just created. And now if I say Terraform destroy, this is going to destroy it for me. And I no longer have, after I type yes here, I no longer have this bucket. Same idea as on AWS. Now, the very last thing I want to show you is a Docker example. So I'm going to create here Docker_example. And basically, let's go in there. Let's copy the Google file because that's, yeah, also quite minimal, main TF. So we have at least a base structure here. And this time we're not going to require Google, we're going to require Docker. So this is Kreuzwerker, this is how it's pronounced, I think it's German. And then Docker, and the version here is 4.2.0. And we need to do a couple of things differently here because we're not connecting to a cloud provider, so we're not going to authenticate ourselves, but we want to have an image and also a container. So for provider Docker, we're just going to provide empty curly brackets, nothing fancy. And we need two resources. One is going to be the Docker image, which I'm going to call Nginx. Nginx because that's the most simple thing that you can do. Just a basic website on port 80. We can do also some port mapping here, but that is just getting the image and not keeping it locally. So the name of the image is Nginx latest. And then we have the flag keep locally, and that is going to be false. That is just getting the image. And then we have the container. So Docker container, which I'm also going to call Nginx. And the image of this container, for this container, will be the Docker image .nginx.image ID. Name, let's call this tutorial. And then we can define ports. So port mapping, we can say internal is going to be port 80 and external is going to be 8000. And then we could do some port mapping as well. So ports, we're going to say that we have internal being equal to 80. That's the port Nginx serves. And then external, we want to map this to 8000. Super simple setup, nothing fancy. We don't need any auth for that. I just need to say again, Terraform init to actually get the plugin, the provider plugin. Then we can do validate to see if I made some typo again. Oh, this time I didn't. Great, apply. And then this is going to run everything here locally with a container. So this actually spawns a Docker container, creates the image and gets the container running. Then I can do Docker PS. You can see it's running. And if I now say Terraform destroy, it will reverse that. I say yes. I do Docker PS, container is gone. That is the magic of Terraform. Very, very basic, just a quick start guide, but you can easily define setups with AWS, GCP, Azure, all the different providers, and you can just apply, destroy, super simple, and you can reproduce it on different systems. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, in case you're interested, on my website, you will find a services tab and a tutoring tab. There you can contact me if you need help with a project, if you need a freelancer or a consultant. At the bottom of both pages, you will find a link to the email and also to LinkedIn. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.